Hello everyone, I am Aradhya Balamurali Krishna from Krishna University, pursuing electronics and communication engineering. In this video, I will be presenting my internship project titled Washing Machine Stimulation using PIC16F877A microcontrollers, completed as a part of internship at emertxe. This project stimulates the behavior of the basic washing machine using a microcontroller and amended C program. Goal of internship. The primary goal of the internship here to learn and apply embedded system C programming, understand how to work with the PLC16F877A microcontroller, and interfacing various hardware peripherals like LCDs, timers, and buttons. Stimulate a real world applications using embedded development tools. Tables of contents. Here's what we'll cover in this video. Introduction. Embedded system C overview. Embedded system basics. Types of embedded systems and microcontrollers and PLC16F877A. Objective of the project. Software tools used. Hardware block diagram. Project demo. Conclusion. Embedded system C language. Embedded system C is a very version of the C programming language optimized for microcontrollers. It allows direct access to hardware registers and uses features like loop and conditions to manage a logic. Interrupts to respond to events like button pressing. Functions and macros for modular code. It is efficient and lightweight and ideal for embedding system like our washing machine projects. So what is embedded system? An embedded system is a combination of hardware and software built to perform a specific task. These systems are found in smart TVs and washing machines, micro ovens, medical industries, and they typically involves a microcontrollers programmed to handle a real time tasks. And here, types of embedded systems. There are five major types of embedded systems. Standalone system like old washing machines, network system like home automations, and real time systems. Its works our project is a real software like real time systems where slightly delays are acceptable. Mobile embedded systems like fitness trackers and hybrid systems such as robotics and self-driving cars. So what is microcontrollers? A microcontroller is an integrated circuit which has CPU, memory, and input and output ports. It takes input from the environment and processing it and produce an output. In our project we use the PLC16F877A, which is in an 8-bit microcontroller with 40 pins and 5 inputs output ports, built-in terms, serial and SPI communication supports, and also operating frequency from 4 to 40 MHz. Objective of the project. The objective of the project is to stimulate the basic washing machine operations using the PLC16F877A microcontroller, which automates washing machine, rinsing, spinning. The system used push button for use control, a 16:2 LCD for display, and timers to manage each cycle accurately. Software tools used. The following tools were used to develop the stimulate this project: MP Lab XIDE for writing and compiling the embed C code, X8 compiler to generate hex file from code, Pixing Lab or Proteus to stimulate the circuit design virtually and observed the result block diagram of the washing machine stimulator. The system is designed as follow: inputs are received from these buttons. They are RB3 for mode selection and RB4 to start, RB5 to pause. The PLC16F877 microcontroller processor. These inputs, timer 2 is used for timing control and 16 into 2 LCD display the current state and countdown. LEDs and fans stimulates the motor behavior for washing and spinning purpose. A buzzer indicates the end of the cycle. Project demo. Let me show you how to stimulation work. I am pressing the start button RB4. The LED display washing started and the washing LED turns on. After a few seconds, it switches to rinsing and then spinning each control by timers 2. The corresponding LEDs is indicated each state. Finally, a buzzer sound to indicates the washing cycle has completed. If I press the pause button RB5, the system temporarily halts. Pressing it again resume the operation. This clearly shows how to stimulate mimics real world functionality of the washing machine. Conclusion. To conclude, this project is successfully demonstrate the working of the microcontroller based washing machine. It integrates peripheral like buttons, LEDs, LCD, timers and interrupts, and it's going to valuable experience in the programming, debugging and hardware stimulations. It has laid a strong foundation for future projects in embedded systems and IoT. Of course. Uh, Thank you.